Yeah. Make sure the coefficient of x squared is 1, if not divided out. It is 1, so I really don't need to do anything. Variables on the left, numbers on the right. Complete the square by taking b over 2 or 1/2 b. Well, I've got a number 4, so I don't have a fraction. So I'm going to take minus 4 over 2 and square it, which is minus 2 squared, or 4. That number I'm going to end up adding to both sides. So I'm going to have x squared minus 4x equals negative 8. Add 4. So that the left-hand side is a perfect trinomial square, because we made it that way, and it's equal to minus 4. So square root of x squared is x, center sign is minus, square root of 4 is 2, it's x minus 2 squared. Now use the square root property to solve. Square root of x minus 2 squared equals, and what did, oh, plus or minus, what did I forget? I didn't forget anything. Minus 4. Or that x minus 2 equals plus or minus, what's the square root of minus 4? 2 what?
2i.
2i. Or x equals 2 plus or minus 2i. 2 doesn't have an I, so I can't make it part of the 2i. And you just leave it that way. Can't be simplified anymore. And they're imaginary, so you couldn't even graph it.
I'm sorry, why did you say that you can't have a minus 2i? Just because you can't?
Well, the problem tends to be you can't bring this 2 in with that 2i, because this 2 doesn't have an I.
Oh.
Yeah, I mean, they have to be like terms and are not like
You
terms.
just leave it plus or minus.
Yeah. So it's 2 plus or minus 2i. And notice, by the way, they're conjugate pairs. If I were to write this out, x is equal to 2 plus 2i, x is equal to 2 minus 2i. They're conjugate pairs. And why? Because the only sign that changes is the one in the middle. Conjugate pairs. Cool, huh? Uh-huh. Okay. Coefficient, x squared 1, and it is 1, so we're not going to do anything there. Variables on the left, numbers on the right. So I'm going to complete the square by taking the coefficient of x, which is negative 3, thank you, divided by 2 and square it, which is 9 over 4. And I'm going to add 9 over 4 to both sides. Now I'm going to have to do a little work, because I'm going to have to add 5 to 9 over 4, which means I'm going to have to write 5 in fourths, so 4 over 4. Left-hand side's a perfect trinomial square. This is x, center sign is minus. Square root of 9 over 4 is 3 over 2. This is going to be 20 over 4 plus 9 over 4. Or x minus 3/2 squared is 29 over 4.
Why did you do 4 over 2?
Pardon me?
Why do you do 4 over 2?
Because I needed to have a common denominator of 4. 5 has a denominator of 1, and so I couldn't bring the 5 and the 9/4 together because they didn't have the same denominator. Now use the square root property on both sides, and I need the space, so, well, I've already started it. So this says that x minus 3/2 squared equals plus or minus the square root of 29 over 4. Or that x minus 3/2 equals plus or minus, well, the square root of 29, that's prime, and square root of 4 is 2. Or x equals, add 3/2 to both sides, plus or minus the square root of 29 over 2, and then you can just leave it that way.